Alrighty, so here's another series of numbers starting with 2, then 6, 12, 20, etc. We'll just start with those four, see if we can figure this out. So same process as before, write a table in terms of n. Let's have a look at what's changing here. See if you can try to figure out how this is changing every time and try to write it out in some kind of equation format. Go ahead and give it a shot, see what you come up with. Okay, well this is a really good example of probably trial and error for you because you maybe started doing something like this. I don't know what you did. You did something on your own. I don't know what you did. But sometimes the way we think the pattern is going is really difficult to describe. So we start going down one path, and it's just really tough to figure out. So for example, if you could do it like this, it's saying it's 2 plus 0, which is 2, or then 2 plus 4, 2 plus 10. And you go, okay, well this goes up by 4, and this goes up by 6, and this goes up by 8. And so you could try to make some kind of pattern there, and definitely you could make that work. But it just gets a bit more complicated. So again, let's go back to looking at n. Is there some other way we can look at this in terms of n? So for example, the first term is 1 times 2, n times 2. Then this is 2 times 3. This is 3 times 4. Oh, and this is 4 times 5. The next one's 5 times 6. Maybe there's something going on there. In other words, I keep doing n times n plus 1. And does that work for every single one? You bet it does. N times n plus 1. Okay? And so if I wanted to know what the sixth term was, I would just go 6 times 7 is 42. So the sixth term is 42. Okay? So that's kind of how this process works. It's a lot of trying different things, trying to relate it back to n, and come up with something that way. So for this next one, I'm just going to let you go totally on your own and see if you get the same equation I did. Here's the next one. Okay, so there's a table for you all set up. See if you can figure out, go ahead and pause the video, try to figure out an equation for that one. I'll give you the answer starting in 3 seconds. Okay, so you again notice there is some kind of pattern here. First I add 8, then 14, then 20, then 26, and the number I add always keeps going up by 6. So some kind of pattern there, but I want to write it in terms of n rather than just some kind of random pattern like that. Okay, so it's the first term is 1 times 2, the second term 2 times 5, then 3 times 8, 4 times 11, 5 times 14, and so those numbers 2, 5, 8, 11, and 14 are a linear sequence. They go up all by 3. 2 plus 3 is 5, plus 3 is 8, plus 3 is 11, plus 3 is 14. So I can figure out I'm doing n times something. I can figure out an equation for that separate sequence. So it's kind of like two problems built into one. Okay, so if I just make another table then, and how can I make up an equation that describes that sequence there? Again, in terms of n. Okay, well these are all going up by 3, so what happens if we multiply n by 3? Like for example, if I say did 3n, well that would be 3, this would be 6, this would be 9, 12, and 15. Are you noticing what I'm noticing? They're all just 1 too high. In other words, these are all like 3n minus 1. Right? 3 times 1 minus 1 is 2. 3 times 2 minus 1 is 5. 3 times 3 minus 1, etc., etc., etc. So I'm actually multiplying by 3n minus 1. Okay, let's go back up here to this equation here. So there's my series of numbers is at work. N times 3n minus 1. Well, if n is 1, it's going to be times 3 times 1 minus 1. 1 times, well, this is 3 minus 1 is 2. 1 times 2 is 2. And that's the number we get right there. Okay? Do the next one, or one of the other ones. Let's do 3. Okay? So 3 times 3 minus 1. 3 times 8 is definitely 24, which is what we were expecting. Okay? Okay, so that's the math part done. There's just one other bit of logic I need to tell you about. That'll be the next video, and that's it.